So if you go to the doctor at like 45 with severe hot flashes, mood swings, joint pain, you might expect them to, nod sympathetically and tell you your estrogen is just steadily dropping.
Right. I mean, that is the story we've all been told about perimenopause.
Exactly. But what if they pulled your lab results and saw that your estrogen wasn't crashing at all? What if it was actually violently spiking, like up to twice its normal baseline level?
Which completely shatters the whole mainstream narrative,
Yeah.
that idea of a slow, linear decline into menopause.
Yeah.
The reality is that the transition is not this gentle fading of the light. It's a highly active, incredibly turbulent period of systemic rewiring.
Welcome to another deep dive. Today we are looking directly under the hood of a universal yet just fundamentally misunderstood biological process. And for you, our resident learner, the mission today is to zoom in on exactly what is happening inside the ovaries during perimenopause.
It's wild in there.
It really is. We are unpacking a fascinating stack of sources today. We've got the latest medical guidelines from the British Menopause Society, the clinical pathways from NICE, that's the National Institute for Health and Care Excellence, and some intensely revealing pathophysiological research on ovarian aging.
And what those sources show is just a landscape of cellular scarring, mitochondrial breakdowns, and a hormonal feedback loop that practically goes rogue before it finally powers down.
So to understand that rogue feedback loop, we need to establish what the body is actually working with from the very beginning, right?
Right. Because the entirety of female reproductive biology is governed by a finite resource, which is the ovarian reserve.
Which consists of primordial follicles. And each of these is essentially a tiny sac inside the ovary containing an immature egg, or oocyte, surrounded by a layer of support cells.
Yeah, and the numbers detailed in the research here are just staggering.
Oh, they're crazy.
Yeah.
A female infant is born with roughly 1 to 2 million of these primordial follicles. But by the time she reaches menarche, her first period, that number has already plummeted to between, 300,000 and 400,000?
Yep. And then by menopause, usually around age 51 or 52, there are only about 1,000 left.
Which, honestly, the math there is what trips up a lot of people.
Oh, absolutely, because it just doesn't seem to make sense at first glance.
Right. During a typical reproductive lifespan, a woman might ovulate around 400 times, 400 eggs released. So how are hundreds of thousands of follicles just disappearing?
Well, they're lost through a continuous baseline biological process called atresia.
Atresia.
Yeah. It is essentially programmed cell death. I mean, the vast majority of follicles are never destined to be ovulated. They receive a biological signal to self-destruct, and they simply degenerate and are reabsorbed by the ovarian tissue.
Wow.
This isn't a malfunction, it's a natural design of the system.
But it isn't a constant, steady drip either. The straw plus 10 staging system, which the clinical guidelines use as the gold standard for classifying reproductive aging, shows that this rate of atresia shifts drastically.
It accelerates.
Exactly. As a woman enters her mid-30s, the rate of follicular depletion accelerates significantly. The reserves just start vanishing at a much faster pace. So it's not like a vending machine where you just dispense 1 egg a month until it's empty.
No, yeah.
It's more like a bank vault, where the currency is slowly dissolving over time, and then the vault itself starts dissolving faster in your 30s.
That's a perfect analogy.
Yeah.
And that acceleration is the invisible trigger for everything that follows.
Yeah.
Because the body's monitoring systems are constantly sensing the size of that reserve.
Like checking the bank balance.
Right. And the communication between the ovaries and the brain relies on those support cells we mentioned earlier, the granulosa cells that surround the egg inside the follicle.
And the sources point out that these granulosa cells produce a hormone called inhibin B, which honestly gets almost zero attention compared to estrogen or progesterone.
None at all. But the research identifies inhibin B as the true first domino to fall in the menopausal transition.
Wait, really? Not estrogen?
Not estrogen. Inhibin B is the master regulator of the early transition. Normally, it acts as a chemical brake pedal. It travels from the ovaries up to the pituitary gland in the brain and essentially says, we have an adequate pool of growing follicles down here. You can hold back on producing follicle-stimulating hormone, or FSH.
So it's keeping the brain's stimulation in check.
Exactly. But as that follicular reserve accelerates its depletion in a woman's late 30s and early 40s, there are simply fewer granulosa cells to produce inhibin B.
So the brake pedal lifts.
The brake pedal lifts, inhibin B drops, and the pituitary gland is no longer receiving that negative feedback. In response, it just starts pumping out massive amounts of FSH. It floods the system, basically screaming at the ovaries to get to work.
So the brain senses a shortage and tries to force production. And this is where the biology gets incredibly counterintuitive, because you'd assume that the ovaries being depleted would just fail to respond.
You would think so.
But they don't. They actually mount a massive chaotic response to that flood of FSH.
They really do. In a normal cycle, the body recruits a small group of follicles, but usually only a single dominant follicle survives to ovulation.
Right.
The rest undergo that atresia process. But under this emergency flood of high FSH from the pituitary, that normal, elegant selection process just breaks down completely.
The excessive FSH forces multiple follicles to mature all at once.
Yeah, the ovary throws everything it has into the process, recruiting a much larger cohort than normal. And because you have multiple follicles developing simultaneously, they're all secreting estradiol, the main form of estrogen.
Wait, here's where it gets really interesting. You're saying estrogen actually goes up and fluctuates wildly before it goes down.
Oh, it skyrockets. The ovaries are suddenly producing superphysiological levels of estrogen.
Yeah.
The clinical data shows spikes that are often twofold higher than a woman's normal baseline. You end up with these extreme peaks superimposed over the already fluctuating menstrual cycle.
Is this why the early perimenopause symptoms are so chaotic?
Exactly. Women experience heavy bleeding, intense breast tenderness, severe migraines. These aren't symptoms of estrogen deficiency. They are symptoms of estrogen excess and volatility. The hormone is spiking to abnormal heights and then crashing back down.
It's just a highly turbulent environment, but this brings up a massive question regarding the medical guidelines.
Okay.
If we know this massive estrogen spike is a hallmark of early perimenopause, why do the British Menopause Society and NICI explicitly state that doctors should not use hormone testing to diagnose perimenopause in women over 45? I mean, if it's spiking to twice its normal level, wouldn't a ridiculously high estrogen read or a high FSH read be a dead giveaway? Why not use the spike itself?
Because the spike is erratic. It's not sustained. You are trying to measure a chaotic weather system with a single snapshot.
Oh, I see.
If a clinician draws blood on a Tuesday during one of these surges, the estrogen will look incredibly high, and the FSH might actually look suppressed because that high estrogen is temporarily pushing back on the brain.
Right.
But if they draw blood on Friday, the cohort of follicles might have crashed, estrogen could be through the floor, and FSH could be sky high again.
So the blood work is essentially useless because the volatility is the defining feature, not the absolute number on any given day.
Exactly. The clinical guidelines recognize that symptoms and changes in cycle length are far more reliable indicators of this biological chaos than an isolated hormone panel, because the physical tissue of the ovary itself is undergoing structural changes that a blood test simply can't capture.
Let's dig into that physical tissue because the pathophysiological research in our sources goes deep into the microscopic changes. We know oocytes are some of the largest and most complex cells in the human body.
Very complex.
They are incredibly energy intensive, requiring a massive amount of ATP to mature, divide, and potentially support early embryonic development.
And that energy demand makes them heavily reliant on their mitochondria. But during the perimenopausal transition, those mitochondria suffer from acute degradation.
The power grid starts failing.
Exactly. The research highlights a heavy burden of oxidative stress, specifically reactive oxygen species, or ROS.
So the cellular environment essentially becomes toxic to its own power grid. The oxidative stress causes direct damage to the mitochondrial DNA.
Yeah, so the energy production within the egg starts to flicker and fail. But it's not just the eggs that are degrading. The NICE guidelines spend a lot of time on the microenvironmental alterations of the entire organ.
The actual landscape of the ovary is fundamentally transforming.
Right. The literature details a sharp increase in fibrosis. When we look at the ovarian stroma, the connective tissue framework of the ovary, we see a state of chronic inflammation and reduced angiogenesis.
Meaning a decrease in the blood vessels that deliver vital nutrients.
Yeah.
You know, the detail that really stood out in the research was the behavior of the macrophages. Normally, macrophages are the immune system's cleanup crew, right? They should be clearing out cellular debris.
Right, that's their normal job.
But during this transition, they shift into a profibrotic state. They actually start laying down dense scar tissue throughout the ovary.
Yeah, the structural integrity of the organ is basically becoming rigid. And while this physical scarring is happening, the genetic instructions guiding the remaining cells are also becoming corrupted.
Like the FOXL2 gene mentioned in the sources.
Exactly. The sources highlight specific mutations, such as in the FOXL2 gene.
How does that specific mutation impact the transition?
Well, FOXL2 is critical for the proper function and differentiation of the granulosa cells, those support cells we talked about earlier.
The ones that make inhibin B.
Right. When FOXL2 mutations occur, or when epigenetic changes alter how the genes are expressed, those granulosa cells essentially experience cellular amnesia.
Wow, cellular amnesia.
Yeah, they lose their ability to support the follicle, they fail to produce hormones correctly, and they can't protect the egg from that mounting oxidative stress.
So if the ovary is a factory, it's not just that the raw materials, the follicles are running out. The machine is rusting, the power grid, the mitochondria is flickering, and the building itself is getting filled with scar tissue.
That is exactly what's happening.
Yeah.
It is a profound systemic shutdown at the absolute microscopic level.
Which brings us to what the straw plus 10 criteria classifies as the late menopausal transition, the tipping point.
Yes, the point where the chaotic spikes finally end.
Because eventually the follicles are so severely depleted and that microenvironment is so heavily scarred that the ovaries simply stop responding.
Right. The brain is still flooding the system with screamingly high levels of FSH, but the ovaries can no longer recruit a cohort of follicles.
There's no massive surge of estradiol.
None. At this stage, the estrogen levels finally plummet and remain low. And because ovulation ceases entirely, there is no corpus luteum formed.
Which means progesterone levels also drop to near zero.
Exactly. Other markers, like anti-Mullerian hormone and inhibin A, become completely undetectable in the blood.
The factory has basically closed its doors.
It has.
And this final sustained crash is what triggers the classic symptoms that most people universally associate with menopause. But the neurological causality behind those symptoms is fascinating.
Oh, it really is.
It's not just that the body is simply missing estrogen. The sudden withdrawal of estrogen physically rewires the hypothalamus in the brain.
Because the hypothalamus is the body's control center for various autonomic functions, including temperature regulation.
Right.
When estrogen levels rapidly drop, it triggers an overactivity of certain neurotransmitters, primarily norepinephrine and serotonin, within the hypothalamus.
And the research explains that this neurotransmitter shift causes a narrowing of the body's thermoneutral zone. Think of the thermoneutral zone like the lane assist feature in your car. Normally, you have a fairly wide lane. Your core body temperature can fluctuate a little bit up or down depending on the environment, and you can drift slightly without the car or the brain doing anything drastic to correct it.
But estrogen withdrawal paints those lane lines right up against your tires.
Yes. The buffer zone practically vanishes. The upper threshold for sweating decreases and the lower threshold for shivering increases. The margins become razor thin.
So a tiny, completely normal increase in core temperature, maybe from drinking a hot cup of coffee or just walking up a flight of stairs, causes you to cross that new lowered upper threshold.
The brain instantly panics. It assumes you are dangerously overheating and violently jerks the steering wheel to correct it.
It triggers massive vasodilation. Blood vessels near the skin suddenly widen to dump heat, and the body initiates profuse sweating to cool you down.
That is the biological mechanism of a hot flush.
Exactly. And the cruelty of the narrow thermoneutral zone is that as soon as that sweat cools your skin even a fraction of a degree,
you cross the newly raised lower threshold.
Right. The brain panics in the exact opposite direction. It thinks you are suddenly freezing to death and triggers intense involuntary shivering.
The extreme temperature swings are a direct result of a neurological miscalibration caused by the estrogen withdrawal. It just highlights how deeply interconnected the reproductive system is with the central nervous system.
It's incredible.
So when we look at the entire scope of this biological process, what does it mean for you, the listener? If you or someone you know is navigating wild mood swings, joint pain, heavy and erratic bleeding, or severe hot flushes, it is vital to understand that this is not just a vague, inevitable symptom of getting older.
No, not at all.
The chaos experienced on the outside is an exact mechanical mirror of the profound biological chaos happening at the microscopic level. The spiking hormones, the mitochondrial degradation, the immune cells laying down scar tissue, and the brain's compromised thermostat. It is a highly active, physically demanding systemic transition.
And understanding the mechanics validates the physical reality of the experience. It strips away the mystery and the dismissal that often surrounds women's health, replacing it with hard, measurable biology.
Definitely. But There's one final piece of this pathophysiological research that we have to explore before we finish, and it addresses a truly mind-bending question.
Oh, the timeline.
Yes. When is the specific timeline of this complex cellular breakdown actually decided? We know that genetics play a role in whether you hit menopause at 45 or 55, but the sources highlight a massive external variable: reproductively toxic environmental chemicals, or RTECs.
Because the modern environment is just saturated with these chemicals. We're talking about endocrine disruptors like bisphenol A, BPA found in plastics,
Mhm.
phthalates used in cosmetics and packaging, and various agricultural pesticides.
Right.
The literature shows that adult exposure to these chemicals absolutely accelerates ovarian aging. But the most alarming data comes from what happens before a woman is even born.
The cross-sectional human surveys and animal models point to the impact of in utero exposure, meaning, while a female fetus is still developing inside her mother's womb,
While that fetus is developing, her body is actively assembling her lifetime supply of primordial follicles, that initial reserve of 1 to 2 million we discussed at the very beginning.
yeah.
If the pregnant mother is exposed to high levels of RTECs, those chemicals cross the placenta and interact directly with the developing germ cells of the fetus.
And the research specifically cites how these chemicals alter DNA methylation. Think of DNA methylation like a complex series of volume knobs on your genome.
Right.
The genes themselves aren't necessarily mutated or deleted, but the chemical environment can reach in and physically turn down the volume on the specific genes responsible for healthy follicle growth, or turn up the volume on genes that trigger early cell death.
The environmental exposure essentially reprograms the epigenetic software of the ovarian reserve. It sets a new, accelerated trajectory for how quickly those follicles will deplete decades later.
Just let that implication sink in for a second. The structural integrity of your ovarian reserve, your vulnerability to oxidative stress, and the exact timeline of when you will hit that chaotic perimenopausal roller coaster might have been biologically locked in by the chemical environment your mother was exposed to before you took your first breath.
It is a profound example of transgenerational biological impact. The perimenopausal transition is a modern physiological event, but its countdown clock may have been calibrated by a completely different environment a generation ago.
It fundamentally changes how we view the life cycle of the ovary. It's not just an organ that slowly runs out of eggs. It is an incredibly complex, highly reactive biological engine.
An engine that mounts a massive, chaotic defense against its own depletion.
Exactly. It rewires the neurological pathways of the brain in its final act, and it carries the epigenetic scars of an environment that existed decades before it ever started to shut down. It gives an entirely new weight to what the female body endures during this transition.
It really does.
Something for you to absolutely chew on long after this deep dive ends. Until next time, keep questioning and keep learning.